Wonderful. Well, thank you for joining me this evening. I hope this is going to be a fun tour of personally some of my favorite places that I've been able to travel and some that I'm looking forward to going to. But the reason why we're here tonight and why I've been traveling to these places is not to understand what is going on Earth, but to use the Earth to figure out what is going on Mars. So how does the geology of Earth help us figure out the geology of Mars? And so I'm so excited to share with you what planetary analogs are and the types of research that these planetary analogs allow us to do. So a quick definition, and there are probably many definitions, but when I think of a planetary analog, I consider it as a landscape or an environment or a feature, which a feature can be as small as a rock or as big as, an entire dune field. What are all of these different types of things that could be similar to places in our solar system? And that includes our moon, that includes Mars, asteroids, moons of Saturn and Jupiter. So those places on Earth that we can find that are similar to where we think those places are elsewhere in the universe. And these planetary analogs help us understand how the geology and how these different planetary bodies formed over time. And so all of the bodies in our solar system, none are like Earth. Earth is a very special place. And so something happened along the way over these billions and millions of years that was a little different in how the surfaces and their subsurface features evolved over time. But we can use Earth to help us kind of unravel what happened. So in the background here, I will say that most of the pictures are of Earth, although I wish I had been to some of these other planetary bodies. But I threw in some of my favorites because I just think, especially with a foggy day like this in Iceland, it's just remarkable how much this could look like an astronaut on the moon or even on Mars one day. So I like to take pictures like this when I'm in the field because it's a reminder of just how similar Earth is to the rest of our solar system. So talking about planetary analogs, we can use them in totally different ways. So we can use orbiters from the Earth and from Mars to kind of look at these large scale features. So you'll see on the left panels of each of these images, these are images from satellites that are showing, river networks on Earth. And those are being compared to these same, what we think are ancient, dried up river systems on Mars. So this is a perfect example of kind of these like zoomed out large scale features and ways that we can use Earth and Mars to understand the geomorphology that's happened on a large scale. We can zoom in and look at surface processes. So these are dunes on the left on Earth. These are in Iceland. And then this is a picture from the Curiosity rover that drove through a dune field. And you can see those similar ripples on the dunes on Mars. So we can kind of start to zoom in and use these environments to show us different size scales. And then we can go even further and look at rocks. And so the rock on the left is another image from the Curiosity rover. It was looking at this sedimentary rock, so this conglomerate type rock that had these pebbles falling out of it. And they're very rounded, which is similar to these kind of river pebbles and sediments that we see here on Earth. So we can go large scale geomorphology all the way down to individual rocks and minerals. And these are all considered, part of this planetary analog suite of materials and this type of area of study. So one of the other things that we use analogs for are to practice going back to the moon and going back to Mars. So there's no better way to practice than to be in a landscape where there's not a lot of bushes that you have to get around. There's not running water. And so you'll see here on the left, this is Xena. She's an astronaut right now. And so she's practicing along with her colleague. I'm actually not sure who that is, but these are pretending of how they would traverse around on the lunar surface, how they would use tools, how they would go about sampling. And so we not only use planetary analogs to understand the science and the geology, but they're really important as we're starting to prepare to explore these bodies so that we can immerse our crew in environments that seem the most similar and have those rocks and those features that are most similar to what we may see on the moon. So let's get back to Mars. Well, where on Earth can we study Mars? And to be honest, there's a ton of places. So all the way from the south in the dry valleys of Antarctica, all the way to the north in the Arctic and Svalbard, there are places all over this Earth that have features and rocks and geologic landscapes that really help us understand Mars. So I'm going to focus on 3 of these places today. One is Hawaii. The next one is Iceland. And then the last one I'll just really touch on is Alaska, which is a new one to me. And I never thought Alaska would be a place to study Mars. So I'm excited to tell you about that one. All right, so let's kick it off. Let's take a trip to the big island of Hawaii. So this is a picture from Google Maps. You can see Hawaii in the middle. There's actually 7 different volcanoes that make up this island. And I'm sure you've seen in the news, as with Iceland, this is still a very active island. So we still have volcanoes erupting every so often. And most of those volcanic eruptions are on kind of the southern part of the island. But Hawaii is one of the classic places where people have been studying Mars for decades. So I'm going to point out a couple things, and I'll kind of ask these in questions. So these are some of the questions that we ask when we go to these different places. Now, this may not look like Hawaii. I'm sure if any of you have been to Hawaii, it's probably not to go to a lava tube, but it's probably to sit on a beach somewhere and enjoy a nice fruity drink as you're basking in the sun. When we go to Hawaii, a lot of our time is spent underground. And that's because there are these structures called lava tubes. And these are actually hollow caves that form as lava is erupting and cooling. And this is so cool. So you'll see this is kind of in the middle of the lava tube, and that dark hole ahead is where we really are interested. And why we want to know about lava tubes and subsurface environments on Mars is because this could be protection from the really harsh radiation environment on Mars that maybe could have protected microbes, whether they're living or not today, who knows, but it could have provided shelter for these microbes and also provided a different type of mineralogy. So different environments where we could have different minerals than what we see on the surface. So we send our researchers into these lava tubes. And what's really cool is you can see these almost little dripping like features. That's as the lava dripped down and cooled, it hardened. And it's so cool. And then on top of this, you see all that white material. Those are really unique minerals that form because of all of these gases that are moving through and just kind of precipitating on the surface of these. So a very different environment than what we see on the surface and what you would think from a lava flow, but something that's really cool for our microbiologists and our astrobiologists to study, to understand if these environments could have promoted or even helped microbes kind of grow and flourish in the subsurface. And then if I take this back to exploration, these environments, just like they would be sheltering our microbes from this radiation, could also be a shelter for humans one day. So if there are safe ways that we can access these lava tubes, then it could provide some relief from the harsh radiation environment, not only on Mars, but also on the moon. So really cool places to study. And then the last one, speaking of the moon, I'll talk about in Hawaii is this absolutely amazing structure called a pit crater. So on the right-hand side, you'll see a feature that was imaged by one of the orbiters on the moon, and it took a picture of the structure. And if you look on the left, this is the same type of morphology that we see, this round structure. And it's really hard to see, but there's a tiny human here. And so you can see there's really large scale structures. But things like this are really, ways that we can compare these large scale features on both the moon and Mars to what we're seeing on Earth. And so by exploring and studying these features on Earth, we're really understanding the processes on the moon and Mars. All right, so let's fly across into the other ocean on Earth, and let's go to Iceland. So I have to say, I have been more than fortunate to travel to Iceland about 4 times now, and absolutely amazing. One of my favorite places to go. I never thought I would be able to do this, but one of the wonderful perks of this job is being able to visit these really amazing places. So Iceland provides just a fabulous environment to study Mars. Right now, there's an active volcano going, and so not only can we get these really young processes, but Iceland has formed from many volcanic eruptions over time. So we can kind of track how these volcanic processes are impacting the different types of materials that we might see on Mars. So I'm going to highlight one of my favorite projects, and this is a project that my colleague is in charge of, and I was fortunate to serve as a field hand. But it's called the Dig Mars Project. My colleague and I both work with the Curiosity rover, and you'll see the selfie of the Curiosity rover on the left. And the Curiosity rover is exploring this place called Gale Crater on Mars. And it's a large crater, but it's a little odd because there's this big hump kind of mountain in the middle, and then there's these really smooth areas around. And so, it was a really curious place for the Curiosity rover to go. One of the hypotheses is that these smooth areas were actually an ancient lake. So we had all of these deposits that were coming from the crater rim. So these rocks that as rivers were coming in were being deposited into this lake. And so you have those sediments and those pebbles and everything are coming in, just like you would a river depositing these sediments, say, into the Gulf of Mexico on Mars or on Earth. And so this is kind of one of the hypotheses that's going on. So another thing that people think are happening is not only do you have water and sediment coming into this lake, but you have groundwater that's also altering these materials from below. And so my colleague decided to use Iceland as an analog to try and figure out if we can mimic these processes that we see on Mars. And so he chose this lake. Let me tell you, it was a very cold lake in the middle of Iceland. There are no habits or no structures, no houses, nothing is around. In the distance, you have these volcanoes and glaciers that are feeding the sediments that are deposited into the lake. And then he used a drone with a thermal camera, and it actually shows that you have some warm groundwater. So almost the kind of simple but identical thing that we're thinking could have happened in Gale Crater. And so what my colleague wanted to do is send a bunch of people hiking into those to those mountains above to collect rocks. Thank goodness I was not on that team. And then the rest of us had to go down to the lake. And so we took drill cores and went from kind of the banks of the lake to look at how these sediments were changing with depth. We got even closer, put on some waders, and you just hoped that you didn't draw the one that had the hole in it that day. And we waded out into the water to get even more cores. And then we used this amazing boat to go out even further in the lake. So we had a whole depth profile where we were trying to assess, the rocks that our hikers were getting from the mountains down to the sediments in the lake. And so that was kind of one of my favorite projects that I've been involved with. And there's a lot of great things that are coming out from that and being published. So if you happen to see anything from Michael Thorpe and Dig Mars, if you're interested in that, really cool project there. But Iceland is a big country, and so some other things that we can look at are, how can we use these really young volcanoes to understand how these vents and structures weather over time. And also the glaciers that we see on Mars. Volcanoes actually erupted underneath those glaciers, a situation that we think could have happened very easily on Mars. So what do those rocks and minerals look like from a volcano that erupted underneath the glacier? This happened on Iceland, and so we can go collect those samples to compare to those that are on Mars. All right, so I told you I'd preview a little bit about Alaska. So this is our last place we'll go. It's a little hard to see this here, but this is the Valley of 10,000 Smokes in Katmai National Park. So the kind of light deposits here are basically a huge explosive volcanic range. And so you had a ton of ash coming out, depositing in this area. So why do we care about that? Well, there's this area on Mars. So this is in the lower left corner. This is kind of like the entire map of the Martian surface. And so what I've highlighted here is this area called Arabia Terra, and it's over 6,000 kilometers in length. And it is thought to be the result of these explosive volcanic eruptions. So not that dark basalt that we saw in Iceland, or those really dark rocks, but these are much lighter materials that just erupted, and you had ash coming down across this huge area. And just how huge is it? Well, it's larger than the whole continental United States. But even though it's that large, we don't need to find something on the Earth that's that same scale. We can kind of scale down and use an Earth analog that may be smaller to understand the same type of these volcanic processes that are going on a different planet. And that's exactly what we're going to do in Alaska. So we're using this tiny area compared to this Mars deposits in order to try and understand what we're seeing from these Mars orbiters to understand the surface of Mars. So this is a place I had not been to, and I'm so excited to go. We're starting to plan our field work for Alaska. My colleagues were able to go 2 years ago and scout the area. They joined a field camp with students and learned how we can camp and be safe. This is an area full of bears who just woke up from the summer and or from the winter and are very hungry. So, we're preparing how to conduct this field work in a really safe way, but also learn some of these really amazing features and how they can compare to Mars. So this is something that I'm super excited about. And Stacy, maybe I can come back and share what I've learned with the audience today. But with that, I just want to thank you. This was a quick tour of the analogs, at least some of the places I've been to. As you saw on that map, there are many, many more Mars analogs that help us understand that planet. But I just wanted to share some of my favorites and some of the science that we at Goddard Space Flight Center are doing in these locations to try and understand the red planet. So with that, I will say thank you as we go back to Iceland, and I shot this kind of wonderful picture that reminded me of just how close Earth can look to Mars. So thank